So, okay, one of the questions is, they're word problems, most of them.
Okay.
But it says, a new laptop costs $1,500. The value of the computer decreases by 22% each year. Estimate the value of the computer after owning it for 4 years.
It's the general equation we want to use.
What's the general equation we want to use?
What is it? I always start every math problem out by figuring out what the general equation is.
Isn't it y equals parentheses 1 plus r to the t or something?
It's the amount that it's going to be worth
Oh, right.
equal to its starting amount times 1, in this case, minus r to the t, where r is in, that's your 22%, and t is in years.
Okay.
Now, it doesn't have to be this general formula. There's another general formula that is for continuous decay, which is that one. And nothing really decays annually. In other words, if this was a car, we're talking about a car here?
Yeah.
Well, your car doesn't go from $1,500 valuable on January 1st to $1,200 on December 31st. Doesn't work like that. It depreciates continuously. The problem is that they give lots of students these kind of problems expecting them to use the annual depreciation number. Oh, what happened to my pen? My pen stopped working. Hold on a minute. Let me close it and open it again. That helps. Excuse me for this inconvenience. Hold on, let me unplug it, plug it back in. That always solves it. Let's see if it did this time. Okay, so it was 50. Well, that leaves solution number 3, which is, hold on. Okay, I got my writing back. Do you know which one they want you to use? It could be either one.
I think it's the first one.
I think
so
too. Because usually when they talk about the second one, it has to do with things like radioactive decay.
Yeah, we're not really.
You do decay continuously. In other words, you also have continuous growth, so that one is used for anything that's continuous.
Okay.
But when they state the problem the way this was stated, then usually they want you to use this first one, even though nothing decays annually. And I mean nothing except maybe a bank account or something. I suppose a car depreciating might, because if you look up the value of the car, they assume that they're all exactly some number of years. So let's now fill in the specifics.
Okay.
What's A sub 0?
1,500.
What goes in the parentheses?
1 minus, would it be 0.022?
No. 22% to convert percent to decimal, just always move the decimal 2 spots.
Okay.
So it's 0.22.
Okay.
Just like 0.5 is 50%, because I'm going to move the decimal 2 spots, which makes it 50%. So there's nothing in the world mathematically easier than converting between decimals and percents.
Okay.
It's either divide by 100 or multiply by 100.
Alright.
Okay. So in this case, what goes in the parentheses?
1 minus 0.22.
Well, let's put in a number. That's 0.78. And t is 4. Now, we know t is in years because r was quoted to us as a yearly rate.
Okay.
Had r been quoted as a monthly rate, in other words, let's say the car dropped in value by 22% per month,
Yeah.
then t is going to be in months.
So it'd be
48.
48. Okay.
Yeah. So whatever your rate units are, that's what the units are on t. In other words, t can be in seconds, minutes, days, weeks, years. So there's no set units for t. They're always the same units as whatever r's units were. And that number you're just going to get out of your calculator.
I have my calculator with me, so that'll be
Quite a bit. That's going to be probably only worth about $500.
yeah, it's 555.226.
And I don't know how much he wants you to round it off.
She usually makes us do it to like cents, so it'll just be
0.03.
yeah.
All right, what else you got?
Let's see. This one's kind of similar, but it's solve the simple or compound interest equations.
Okay.
And it says, determine how much interest you will earn if you deposit $450 into an account paying 4% simple interest at the end of 10 years. Write an equation/model, then solve. So it wants us to find the equation and the interest after 10 years.
Okay. You start out with $450?
Yes.
And you're earning 4% annualized once a year.
Mm-hmm.
They want to know what it'll be worth after 10 years, right?
Yep.
So give me the equation I want to write. I'll go ahead and put the original. There's the general equation.
Okay.
Now fill in everything you know.
So, wait, it's going to, okay. Is it going to be a growth?
Well, read the problem again, because I might have misunderstood it. I didn't understand it to be this one. Here, read the whole problem.
Determine how much interest you will earn if you deposit $450 into an account paying 4% simple interest at the end of 10 years. Write an equation/model, then solve.
Okay. So they don't really want amount. They want the amount of interest you earn.
Okay.
Well, the amount of interest you earn is going to be a minus a sub 0, right?
Okay.
I mean, anything in excess of $450 is interest.
Right.
So let's first of all figure out what the value of your money is going to be in total. So tell me what to write.
So it's going to be A equals 450, and then 1 plus, oh, I guess I could just,
Yeah, put those two together as quickly as you.
so then
no
it'll
need
be
to ever write it.
0.96.
What is it?
0.96.
This is appreciation, not decay.
Oh, one.
Better hope. I would hate to put $450 in a bank account and have them take money and have it be worth less than $450 at the end of 10 years.
Okay, so it'll together all equal 1.04.
To what power?
To the 10.
Go ahead and come up with a value for A.
Okay.
This, I'm guessing, is going to be about $800, maybe $700.
This one is 666.11.
Now, how much interest did you earn?
$666.11.
No, that's what the value of your $450 is worth.
So is the
interest you earned is 666 minus 450. In other words, $16.11 is the interest you earned. The rest of it, the rest of it was principal. $450 was yours to begin with. Now, at the end of 10 years, your account's worth $666. Well, anything in excess of $450 is the interest that you earned.
Okay.
Well, I was a little confused when they were asking about interest earned, and then they gave you this interest rate. Because usually when they're asking you about the interest rate, you have to solve for R, and they give you everything else. But that wasn't the case with this problem.
Okay.
What else?
Let's see. Okay, this one's writing an explicit rule for like the nth term.
Okay.
So A is, it goes 6, 18, 54, and 162. And it says to find the explicit rule and then A7.
Okay. First of all, what kind of sequence is this? Is it arithmetic or geometric?
Geometric.
And what is the common multiplier, R?
I'm not really sure.
Well, let's talk about the general formula for a geometric sequence. In other words, the nth term is always going to be the first term times the common multiplier to the n minus 1. Now, I haven't done geometric sequences in a while, so I'm not 100% certain. I would not bet my life on that, but I can test it, right?
Right.
What's the second term?
18.
Well, and the first term is 6. Common multiplier is 3. N is 2, because we're talking about the second term. So that would be 3 to the 1. That's equal to 18. That means I got my formula right. In other words, I merely tested one of these numbers that I can tell. That's the second term, that's the third term, that's the fourth term. So I knew the second term was 18, so I better come up with 18 when I plug it into the formula that I think is right. Okay? So the raw formula is a to the n, or I should say the specific formula, a to the n times 3 to the n minus 1. So there's your formula. And they said they want the seventh term?
Yeah.
What's that going to be?
So that'll be...
Fill it in first and then come up with the number.
Well, do I plug in 7 for n?
Yes, that's why I wanted you to do it this way.
Okay, so it'll be 6 to the third, and then
6 times 3 to the 6th power. Go ahead and come up with that number.
So that'll be 4,374.
Yeah, and that makes sense. If I keep multiplying this by 3, it's going to grow pretty fast.
Yeah.
Just twice more. No, see, that's the fourth term, so I got to multiply it 3 more times 3, and I would get to 4,000. So
Right.
if you wanted the 117th term, you could do it. In other words, A sub 117 is going to be 6 times 3 to the 116th power.
Okay.
And that's what the this is the explicit nth term formula right there. For an arithmetic sequence, the explicit formula is this. It's a sub 1 plus the common difference times n minus 1. And one way to distinguish is with arithmetic sequences, you're always just adding the same number to each term, right? Whereas with geometric sequences, you're multiplying. And that puts that thing in the exponent, not as a multiplier.
Okay.
So that's one way to memorize the difference between the two.
Okay.
All right? What else you got?
Let's see.
These can get kind of hard if they give you a problem like the fourth term is this number, the eighth term is this number. Come up with the formula for the nth term.
There's one that's kind of tricky.
If you have one of those, let's do it.
Well, it wants us to give or write the explicit rule in A7 again, but the geometric sequence is A2 equals negative 12 and A4 equals negative 3.
Okay. All right. A sub 2 equals what?
Negative 12.
And A sub what?
4 equals negative 3.
Okay. So we have our general formula, which is this.
Okay.
Problem is that we don't know what the first term was, and we don't know what the common ratio is either.
Right.
So figuring out all of this, there's 2 variables there. So here's what you do. You have A sub 2, which is minus 12, has to be equal to A sub 1 times R to the 2 minus 1. Don't even need to write the 1. Okay?
Okay.
And I also have the fourth term is minus 3. My niece is popping up here. Boy, Facebook just rules. They can just take over your computer whenever they want.
Oh, I know.
That's a little annoying, actually.
Yeah.
I still don't know the first term, but now the common ratio, the fourth term is going to be 4 minus 1, so you get that. So now I have 2 equations and 2 variables.
Okay.
I can solve a system of 2 equations and 2 variables. Let's see. Probably the best way to solve it is to solve the first one for A. In other words, let's use substitution. So the first one, A sub 1 is going to be minus 12 divided by R, right?
Okay.
Now that makes the second one, minus 3 equals, instead of A sub 1, it's minus 12 divided by R, all times R to the third, which makes r squared equal 1/4. Positive 1/4, meaning r is 1/2. You didn't understand every step that I took there, let me know. Solved that's equation 1, that's equation 2. I solved equation 1 for a sub 1, because we know a sub 1 is the same for both of these.
Okay.
And a sub 1 came out to be 12 divided by r, minus 12 divided by r. So I went to equation 2, and I substituted that for a sub 1, giving me this equation.
All right.
Simplified down gives you r squared equals plus 1/4, making r equal 1/2. And once you know that r is equal to 1/2, now I go back into that. If r is 1/2, a must be minus 24, a sub 1.
Okay.
Now I know what a sub 1 is, minus 24. Now I know what r is, 1/2, so if I want the specific equation for this sequence, it's going to be a sub n equals a sub 1, which is minus 24, times r, which is 1/2, to the n minus 1. And that will give you any term you want. Did they ask for a term? They must have. Or did they just ask for the explicit nth term formula?
They asked for A7, or A sub 7.
So to get a sub 7 minus 24 times 1/2 to the 6th power. Which is like negative 24 over 64.
Okay.
In other words, 1/2 to the 6th power is 1/64th. So it's negative 24 over 64. I can divide both top and bottom by 4. Cut that in half, minus 3/8. A sub 7. Now, just to make sure that everything is copacetic here, let's see if all of that's true. Well, I came up with a first term of minus 24. Second term was minus 12.
Okay.
Third term is going to be minus 6. Fourth term is going to be minus 3. Fifth term is going to be minus 3/2. Sixth term is going to be minus 3/4. Seventh term is going to be minus 3/8, which is what we got. Only this is the hard way to do it. This other way is the easy way. Maybe not the easiest way if they're asking about a sub 7, but if they were asking about a sub 100, we wouldn't want to have to do it the way at the top.
Right.
So when they don't tell you a sub 1 or the common ratio, then you have to solve a system of equations to figure out both of those.
Okay. So those ones are probably, they're a little bit tougher.
Those are going to be the hardest ones you come across, I'm sure. Where they don't give you a sub 1 and they don't give you r.
Okay.
That always involves generating two equations, and always know that if you have the same number of variables as you have equations, you can solve that system.
Okay.
And we had two variables and two equations.
All right. Let's
Got time for
see.
maybe one more if it's relatively.
Okay. see. Okay, this one says, how much, or this is a simpler compound interest question again.
Okay.
And it says, how much money should be deposited into an account earning 6% interest compounding weekly in order to have $3,700 in 4 years?
Yeah, this is kind of a tough problem. First of
Yeah.
all, we don't have the same general formula. There's a different general formula when you compound more often than annual.
Okay.
Okay, and that formula, do you know what it is?
I don't know that one.
Well, it's 1 plus r over n to the nt. So you have to add the n, and what n is how many times per year is it compounded?
Okay.
Well, if we're compounding weekly, what is n?
Well,
How many weeks in a year?
oh,
50,
I don't know.
52.
Oh, okay.
So this means n is 52. If it were daily, it would be 365. If it were monthly, it would be 12.
Okay.
Okay, so what can I fill in this general formula? Hopefully there'll only be one unknown variable left and we'll be able to solve it. In other words, if I only have one equation, there better only be one variable. So what's the big A, the first A going to be?
3,700.
Second one is what we're really trying to solve for. They didn't give us that. They asked us what that would be.
Okay.
Everything else we can solve for. Or they've given us. R is 0.06. Now, notice that they give you R as a yearly rate,
Right.
not as a weekly rate. It's as a yearly rate. But I'm going to divide it by 52. So that gives me a lot closer to a weekly rate. But up here, did they say how many? The question is, what amount would have to be deposited to grow to 3,700 and how many years? I didn't write that down.
In 4 years.
Okay. Because all of a sudden I was looking at a situation where we had two variables. Without a t, then I don't know a sub 1 and I don't know t. I can't solve it. But
Right.
knowing t, and that might look strange to you because you're not used to seeing exponents that big.
Yeah.
The thing is that you're applying that exponent to a number that's very close to 1. So what's 0.06 divided by 52 added to 1 equal to?
Let's see.
Do that part first, just so I can write it properly.
1.00115.
1.000, another 0?
No, just 2 zeros.
And then what are the numbers?
115.
Okay. We're going to take that to the 208th power.
Okay.
Okay. And that's not going to be that big of a number because look at how close. In other words, 1 to the 208th power would just be 1. And
Right.
if it's really, really close to 1, it doesn't grow that fast with exponential growth. Go ahead and find that number first.
All right, so that is 1.27107.
Yeah, see, it didn't grow that much. 1.27107.
Yep.
So now what?
So I should take that and then divide it on both sides.
Correct. So what do you get a sub 1 equal to?
So that is that's 2,910.93.
Yeah, and that makes sense. If you were to deposit $2,910 into a bank account at 6% annual interest, compounded weekly, for a period of 4 years, it would grow to be $3,700.
Okay.
That's what that means. Now, whenever you compound something more often than yearly, it grows a little faster. In other words, if I were to compare annual compounding with weekly compounding's always going to outperform it, but not by a lot.
Okay.
And then continuous compounding is the best of all. That's going to outperform weekly. Because you can think of continuous compounding as being done every single second.
Okay.
Okay? So it'll be a little bit bigger than weekly even. But that's the way compounding works. The more often it's compounded, that's why one bank will say compounded yearly, and the bank across the street will say, we'll give you the same interest rate, but we'll compound it monthly. Well,
Okay.
you're going to deposit your money in the one that's compounded monthly. It's going to be worth it.
Right.
And a third bank, a block away, may say compounded continuously, but only at 5.5%. So to tell which is the best, you'd have to do the math. In other words,
Okay.
you've got one bank at 5.5% continuous and another at 6% weekly, which performs better? And to be honest, I don't know the answer to that. I'd have to do the math. And I would have to know all three general formulas because there's three different ones. There's one for annual. There's one for more often than annual, which is this one. And then there's one for continuous. And continuous is A equals your original principal, P to the RT. And it's E Euler's constant, 2.718. And I could write this A sub 1 also. It's just that PERT is easier to remember than AERT.
Right.
Whatever, with math, you want to use whatever tricks you can use to memorize stuff. Same way that if I said to you, what is the distance, rate, time formula? Do you know what it is?
Not off the top of my head.
That. You know how I remember that?
How? Of dirt.
Exactly. Now, it's also true that R is equal to D over T, but I do not remember that. I don't want to remember that. I only want to remember that one. I can do the algebraic manipulation on my own. As long as I remember the primary one, then I can figure out that T is also equal to D over R. In other words, all of the variations of it are true. It's just that I don't want to clog up my memory with these. That'll just confuse me. If I remember all three of those, then I'm really confused. So the only one I choose to remember is that one, and that's easy. That's dirt.
Okay.
You're never going to get it wrong if you can remember dirt. All right. Anna, you good to go?
Yep.
All right. I will talk to you next week.
Okay. Thank you.
You're welcome. Have a good evening. Bye-bye.
You too.